Welcome to aminacademy.com. In mathematics, CAT entrance, let us do mensuration questions. Look at this example. Water flows at the rate of 10 meters per minute from a cylindrical pipe of 5 mm in diameter. How long will it take to fill up a conical vessel whose diameter at the base is 40 centimeters and depth is 24 centimeters? Here, water flow rate is given in meter per minute and diameters are given mm and centimeters. So you have to convert all in same units wise. Volume of conical vessel, volume of 1/3 pi r squared h is 1/3 pi 20 square. Here whose diameter is 40, therefore 20 is a radius and depth is 20. Depth is 24. So is 8. We have 3200 pi. This is a volume in centimeter cube. Now, water flows at the rate of 10 meters per minute from cylindrical pipe of 5 mm in diameter. We have to do volume of flow. Volume of cylindrical pipe equal pi r squared L. Pi r is 5 mm in diameter. 5 mm diameter is 2.5 centimeter, 2.5 mm radius by 10 is 2.5 centimeter, another 2.5 by 10 into length of the flow is 10 meters per minute. This 10 meter is 1000 centimeter cube now. Here equating both, not equating both, dividing this first one by second one will get. So here the calculation is this cut first. After that we have here 62.5 pi. Therefore time required time to fill equal volume of cone divided by volume of the pipe here, 3200 5 over 62.5. This pi cut, the division gives 51 minute. That means if you divide 51 minutes, after the remainder we have to multiply with the remainder of the decimal, multiply with 60, it gives 12 seconds. It takes 51 minutes per second. Approximately 51 minutes is the correct answer. Next question. All 5 faces of regular pyramid with a square base are found to be the same area. That means in pyramid 4 triangular area as well as square base areas are equal areas. The height of the pyramid is 3 centimeter. The total area of all its surfaces. Here pyramid, one surface is like, and like this, four surfaces as well as one square. Here, height of the triangular face with base A, let it be the base is A. We have to find the height is, look at here, because it is a 90-degree triangle, therefore H equal square root of A by 2, that's a square, plus 3 square, because here the height of the pyramid is 3. Oh, here you have to do height, height of the triangular face, base is here, the height of the pyramid, inside height, this is the height of the face triangle edge, height of the pyramid is 3, therefore your 3 square. Now A equal to edge length of the square base, therefore area of the one triangular base, area of one triangle is half base is A and height is, yeah, A by 2 the square plus 9. Now by the problem, here area of the triangle, one triangle is equal to the area of the square, therefore which is equal to area of square, therefore equating both, have a squared by 4 plus 9 equal a square. So both equating, because triangle, each triangle area is equal to base area, therefore only cut from this we can write it squaring both sides, a square equal here a square equal 1 by 4, the square root will go a squared by 4 plus 9. Therefore from this we can get it 15 a square equal to 9. 15 a square equal to, we get a relation 36. Now the sum of all faces area is sum of all areas equal to 5 a square. That is 5 a square is therefore 5 into 36 by 15, 12. Here from here a square is 36 by 15 and 5 faces is 4 triangle faces, 1 square faces is equal, therefore sum of all areas is 12 square centimeter. Here the piece of string is all uniformly around a triangular prism ABCDEF, is a triangular prism of an equilateral base, equilateral triangle base. The thread starts from one corner A at the base and ends at the corner B, like it's one round, 3 faces round. on the top as shown in the figure. If there are total 14 rounds of the string and the side of the base and the height of the prism are 2 centimeter and 13 centimeter. Height is 13 centimeter, base is 2 centimeter respectively. Then find the length of the string. Here, look at this setup. Here, this is wound around and 14 rounds are there and reach top. So that if you open the prism, it gives a rectangular face like. 13 is height, 2 is one side length, totally 3 sides, and width 14, total rounds are 14. This is the, which is equal, look at here, this is 2 is one side length and 3 is 3 sides, totally 3 sides for triangular prism and side faces as well. 14 is the round, total round. It is, that is here 13. From this, therefore, we need to calculate now one this we have to calculate the diagonals is, which is equal 2 3s are 6, 6 into 14 is 84. Therefore, equal to 84, 84 square plus 13 square, which gives 85. If you multiply 84 into 84 plus 13 into 13, then square root, it gives 85 centimeter. Next question. Here, a circular hall surmounted by a hemispherical roof contains 523 meter cube, 523 meter cube of volume of air contains that hall of air, and the internal diameter of the room is equal to the height of the highest point. Height of the highest point. At point, the roof above the ground. Find the height of the room. Here, volume of the room is given. The circular hall volume. Therefore, radius of the circular hall are equal radius of the circular hall or meters. Radius or meter, and volume of the cylindrical portion. Volume of cylinder equal to pi r squared h, which is equal pi r squared. H is equivalent to radius of the hemispherical. Same h and r is equal here, so we put h r, which is equal pi r cube, and hemisphere volume of volume of hemisphere is 2 by 3 pi r cube. Both together, adding both pi r cube plus 2 by 3 pi r cube is 523 5236. Here 6 is a 5236 meter cube. 5236. Now addition of this pi r cube plus 2 by 3 pi r cube is 5 by 3 pi r cube equal 5236. Then r cube 5236 3 over 5 3 over 5 over 5. Now pi take as 3.142. Pi is 3.142. Then r cube is approximately gives 1000 meter cube. R equal to 10 meter. R equal to 10 meter. We need find the height of the room. Height of the room is 2r. Therefore, which is 2r equal to 20. Two r equal to 20. Now, next question. If a cube of maximum possible volume is cut off from a solid sphere of diameter d, then the volume of the remaining waste material of the sphere is here. The diagonal of the cube is a diagonal of cube equal to diameter of the sphere, because it's fit inside the cubic box. Therefore, the volume of the sphere now, volume of sphere equal to 4 by 3 pi r cube, which is equal 4 by 3 pi r is the diagonal d by the r is equal to, therefore the volume of sphere is 4 by 3 pi d by 2 cube, which is equal pi d cube by 6. Now side of the cube, side of cube is a, is d by root 3. Side of the cube is diagonal of diagonal of cube divided by root 3. Therefore, volume of cube equal to a cube, which is equal d by root 3 the cube. Therefore, remaining volume The remaining volume is that cube of the it means volume of cube minus volume of the sphere by d cube by 6. That is a cube is, here you can write d by root 3 cube minus y d cube by 6, which is d cube by now d cube by 3 we take out, which gives your remaining volume is here first for pi d cube by d cube by 6 minus d cube over d cube over 3 root 3, because d by root 3 whole cube is 3 root 3. So we have to take out d cube by 3. Cube by 3 is pi by 2 minus, because 2 into 3 is 6. D cube by 3 is 1 by root 3. This option that is d cube by 3 pi by 2 by 1 by root 3. This option 2. Next question. Here, question number 14. In a bullet, the gunpowder is to be filled up inside the metallic enclosure. The metallic enclosure is made up of a cylindrical base and conical top with the base radius 5 cm. The ratio of the height of cylinder and cone is 3:2. The ratio of the height of the cylinder and cone. A cylindrical hole is drilled through the metal solid with height 2/3 of the height of the metallic solid. What should be the radius of the hole so that the volume of the hole in which gunpowder is to be filled up is 1/3 of the volume of the metal after drilling. Now, here for this is the front face. Here, a bullet, the gun in the bullet in the gunpowder is to be filled inside the metallic enclosure. This is a metallic enclosure given H1, H1, H2, H3, all the given things. From this, volume 1, volume of the whole body. Volume of the whole body. Let it be V1 equal 1 by 3 pi R1 squared H1 1 by 3 R H1 plus pi R squared H plus cylindrical volume. cone and cylinder by R1 square H2, R1 square H2. So that, look at the ratio H1 by H2 given, the ratios of heights is given as 2/3. Therefore, V1 equal, will apply 3H1 equal to H2. Therefore, which gives V1 is by R1 square into 11 H1 by 6 by using this relation. And H3, look at this. This H3 is the height of the cylindrical hole is equal, given 2/3 of H1 plus H2, which is given equal 5 H1 by 3. 5 H1 by 3. Hence the volume of hole. Volume of hole equal, that is V2 equal by R2 square H3, which is equal 5 by 3 by R2 square H1. But it is given is, look at here, V2 equal V1 minus V2 by 3. Therefore, from this relation, we can get it V1 equal 4V2. Therefore, V1 equal 4, V2 is 5 by 3 by R2 square H1, which is equal by R1 square to 11 by 6. We are substituting 11 by 6 H1. From this relation, we'll get R2 equal 55 over 8. Square root of 55 over 8. That option. Next question. The radius of the cone is root 22, root of 2, not root of 22, root 2 times the height of the cone. A cube of maximum possible volume is cut from the same cone. What is the ratio of the volume of the cone to the volume of the cube? Here, in a cone, maximum volume of the cube is cut. We have to find the relations. What is the ratio of the volume of the cone to the volume of the cube? We have to find by this condition. So, let each side of the cube CD, here this side of the cube, each side of the cube be A, that is, we can say CD equal to now, CD equal to square root of A, because CD is the diagonal of the base of the cube, base face of the cube. Therefore, you can say CD equal root to A. Then CQ, look at this one, CQ is half of that one. root 2a by 2. It is equal to a by root 2 because root 2 wanted to cut, a by root 2 come. Then radius of the cone BR and height is h1. Radius of the cone R equal to radius h equal to height of the cone. Then we can say the relation R equal to h by h into root 2 is given, not h into h into root 2. That is the radius of the cone is root 2 times the height of the cone. So R equal to h root 2. Then triangle APO and CQO are similar. These two triangles are similar. Therefore, we can write triangle APO similar to triangle CQO. From that relation, AP by PQ, AP by PQ equal AP by PO. Sorry, AP by PQ, no, AP by PO. AP by PO equal to CQ by OQ. CQ by OQ, which is equal R by H, radius of the cone. That CQ is radius. That is CQ is half of the diagonal of the face of the cube, and H is the height of the cone, which is further equal a by root 2 because we had done before a by root 2 and a by root 2 and H minus a by root 2 or by H minus a here. Then H minus AP by PO equal to a by root 2 over H minus a. Therefore, a by root 2 over H minus a equal root 2. We have the relation before. From this, we get a equal 2 into H minus a. Therefore, from this, H equal to 3a by 2. A equal to H equal to 3a by 2 to R. Therefore, 3a by 2 into root 2, 3a by 2 into root 2, and therefore H equal to 3a by 2 because therefore volume of the cube is a cube, which is equal, therefore required ratio equal to volume of cone by volume of cube, 9 by 4 by a cube over a cube, 9 by 4 y, which is equal to 2.255. Option 1. We have done. Please subscribe our YouTube channel.